Hello, welcome back. Today we are going to be talking about the camera in our RPG Lite game. I'd like to clean it up a little bit. Right now, the camera is always centered on the player. And that is fine until you get up to the edge of the screen, and then you see that ugly blue abyss off the edge of the map. And what I would like it to do is I'd like the camera to, when it gets to the edge of the screen, to stop. The camera should stay still, and then you'll just see the player moving until the player gets to the edge, until finally the player walks off the edge of this map and moves on to that next map. So, we're going to have to do a little bit of math to help control our camera. Let's get to it. Let's see, where did I put that? Our camera, such as it is basically a little chunk of math in our onUpdate file. Right here. Should the camera move? If so, then do this. Basically, we're telling the level, telling the level to scroll to the sprite X and Y. The display is scrolling to the sprite X and Y minus the display center X. So, we gotta think about how we're going to do this. I'd forgotten that these have two different scrolling options. I think I implemented the scroll to in the level myself, so let's tackle that again. Oh no, I didn't. I did not implement that myself, but that's fine. So defining X and Y, level scrolls to that X and Y value. But for the sprite layer, the X and Y is offset. We have that same math in several areas because we're scrolling if the player moves, but we're scrolling again if the player is changing maps. But that's because if the player changes maps, it's like you moved, but you're not technically moving. You don't have a target tile separate that's different from your actual tile. So we need to refactor that just a little bit. I only want that math in one place. Update the camera based off of a point. That point is the player sprite. Point is anything. We have a point class, but technically anything that has an X and a Y value can be a point. And that is duck typing. Let's use that everywhere that we need to. Right now, we can only handle map transitions going up and down between the town and the field. That is something we are going to address, but I don't know if we'll address it today. So all that math is now in one place, so we can just focus on that. So, let me think. Dot y is less than tile So the Y value of the sprite is less than the center Y. Basically, we're only going to scroll if it's greater than center Y. We gotta tackle four areas for the top, bottom, left, and right. But let's see if we can tackle when you're moving up first. Like only move the camera if the sprite is below the halfway point of the screen. Update camera. Camera. Neat. That's a spelling error. Oh, come on, just fix that. 977? But I didn't save. Okay, do it again. Reset. Reload isn't a thing, but reset is. Don't know why I typed reload. Okay. Testing. You know, that actually didn't change anything at all. Like, that, you can see our player moving up. The Y value is at 1376. Oh, right. Because mini micro, we go down as we go towards 0. I betcha if we do this, going down, and the camera stops. Look at that. That is the effect we were going for. Okay, and it's close to what we're wanting, but we're being attacked by that offset problem that we tackled with our magic math last time. Basically, we have this offset here. Let's see if it's enough just to tack that on. Going down. Oh, nice. That is exactly the effect I was wanting. Okay, now let's do the same thing for the top of the screen. So the upper limit going to be based off the tile level size in pixels minus that same offset. We're just going to call it the square pixel offset. Oh, I forgot. It's different for the top and bottom because you have to either subtract or add the half tile depending on where you're at. Okay, fine. I'm going to have to figure out another way to do that math. So that probably minus the display center because you're starting from the top of the screen and you're going down half of the display. And if the player is above that line, then don't scroll the camera. Y. So you want to scroll if the point y value is greater than the lower limit or less than the upper limit. Let's try that. And let's go ahead and for a player. Somewhere in the middle. Alright. Make sure down still works. No, we broke down. Okay, well, does up work? It's always important to retest the things that you thought you could finish. Okay. Basically, we just broke both directions. Let's try to put that first one back. See what we did wrong. So that puts that limit back. Oh. We want to show the camera if the point y is greater than the lower limit and less than the upper limit, not or. Actually, I don't like to do it like that. It means the same thing, but then it kind of puts the point.y visually between the lower and upper limit, which makes it easier on my head. So the point y value has to be between the lower limit and the upper limit for scrolling to occur. Theoretically. Let's see if I'm right. Okay. Lower limit works. Whoa, that was weird. You see that? It jumped. Sure what that's about. Oh. We needed to scroll in the x direction, even if it's too low on the y value. Otherwise, you can do this. Goodbye, player! Okay, cool. So we're going to break up the x and y party. How do we want to do this? This is only going to contain the y portion. Need some properties on here. We need to be able to retrieve the scroll x and the scroll y. I'll show you why in just a minute. And I'm pulling just the first layer, display for the first layer off because no, we need to make sure that whatever there's a chance that the first layer doesn't have a display attached. So we actually do need to iterate until we find one as a display. But then when we do, we can return the scroll x. Otherwise, we're just going to return 0 by default. Same with scroll y. Now that we have those properties on our tiled level, tell it to, when it's scrolling the y value, level, keep the current scroll x, update the scroll Y. See if that works. Going up. The bug should be the same on the top and bottom. Whoa, that was weird. It's still scrolling, and it's looking like the player's kind of zooming into the distance. Okay. See if the bottom works, and then we'll figure out what happened to the top. No, the bottom's broken too. Okay, so we once again broke that little scrolling thing. X is going... Like, you can still move along the x-axis now, so that's something. Oh, T-level scroll to still has that point Y there, so... I hope. Okay, retest. It works, but it didn't go up high enough, and we can still move along the x-axis. Does the bottom work? I think I know what we need to do for the top. Just want to make sure the bottom works so we can stop worrying about the bottom. Hey, the bottom is perfect. See, I have 3 levels of trees. Wow. Wait, 1, 2, 3. Is this front tile? 2 tiles, half a tile. We're off by half a tile? One, 2, 3. Yeah, we're off by half a tile. I wonder if we actually don't need that part. Oh, math is so fun. The lower limit is that. And let's try taking off this offset completely. Another minus tile display center Y, and we have it again there. Actually, we just don't need it twice. Is tile display center Y minus tile display center Y? Well, that's 0. Well, that's silly. Right, because the camera's position is going to be based off of the lower bounds of the bounding box, which in this case is actually 0. We don't want the camera to be showing anything below y equals 0. That's actually exactly what's supposed to happen. Retest. Check the up. Going north. Wow. Not do what I was wanting. But down here, you see 1, 2, 3 layers of trees, so the bottom is perfect. We can still move along the x-axis. We'll stick that back in. But that's weird. The upper limit was working. Why did it stop working? Don't want the camera to show anything past, like move past the tile level size in pixels. Oh, because we're measuring from the bottom of the screen for the camera, so it needs to be the tile display size in pixels. Full display, which is just the height of the screen. Graphics.height thing. Let's find out. Oh, that is so close. Wait, no, that's right. I think that's right. Well, it's almost right. We're no, that is completely right. So the top of the map is an opening that is two tile. Like there should be two trees there. Let's go back to our level definition. There's the two trees. Oh, I think we did it. I think we have the upper and lower bounds set properly. Now, the fun part. Let's see. NY. Let's change these. It'll make sense in a minute because we actually have two lower limits and two upper limits. X, Y. X, max X. And then doing the left and right side of the screen should be about this simple. Swap all these out. Swap all the Y's with X's. Of course, you know we're going to have to retest it all. What did I just do? I think yeah, that needs to stay like that. I was kind of going nuts there. All right. Hopefully, the last test for this feature. I'm going to test all four corners of our map. That one's blocked. Going around. If you think retesting like this over and over again is boring, you probably do not want to be a video game tester because this would be your job. But you know, it's not really all that different from regular software QA work. Just gotta figure out something that is likely to break and try it over and over and over again. And then do some fixes, try it over and over and over again. Yeah, document it. You gotta be able to write down exactly what caused the bug that you saw. Because if you're just doing the testing, you're gonna have to kick that definition over to somebody who actually knows something about how it was built. Which is actually really important work. Because you don't want bugs like that to be found by the people playing your game, or using your software, or whatever. Right, I think this is done. Oh, let's see what happens when we go into the next map. Well, that's kind of doofy. The transition is kind of broken. We are going to try to fix that transition while we're here today. Not sure why it broke. We're in town 3, moving north. I think it's because or when we're moving like that. Okay. Yeah, the problem is when we're moving north like that, we move to a new map or place at the bounds of the map, and then the camera doesn't update because you're at one of the edges. So the camera position is going to be located exactly where it was before, but all the other pieces will be in the wrong spot. We're going to stick a little parameter here. Force update, normally going to be false. Not force update. Oh, or force update. That parentheses. Split off the ends from the ors. Okay. So if you're changing maps, like if we're updating the camera position because we're moving to a new map, we're going to force the camera to update. Uh, it's well, let me show you. It's not right. I want you to see why it's not right. Moving to the next map. We're gonna move north, and it should force the camera to update. But it updates according to our old rules, placing the player at the center of the screen. What we want to do is basically we want to clamp the camera to a certain minimum and maximum values. So when we do this and the camera's Y value is set to a negative number, it should clamp to 0. Let's make a math function. Clamp equals function, value, exclusive min, exclusive max. If value is less than exclusive min, then return the exclusive min. If the value is greater than the exclusive max, then return the exclusive max. Otherwise, you can just return the value. And we are just going to put those down there, I think. Oh, we do need to clamp the camera values. I'm actually going to take the force update off of those blocks and have it be its own thing. We might refactor this again later. If we're forcing an update, but basically we just scrolled to the player's position and now we want to clamp it. See what that looks like. I got to change this again, but let's take a look. Oh, and if something went wrong, it just kind of stopped there. Did this last thing I had break it? Set, rerun. I don't know. Something weird happened in the environment, but resetting it helped fix it. Okay. Let's see what this looks like. That was weird. Oh my, that's super weird. Okay, so this force update block is just putting it in entirely the wrong position. Because clamp takes 3 parameters, and I'm only feeding it 2. Oh, I think that's the right way to do it. I'm not entirely sure. I, I, I feel good about this top part where we're clamping the scroll X and Y values for the level, but not for the sprite. Let's take a look. The nice thing about this kind of programming is that it's like you can just visualize the math. If you can't, if you're having trouble working out the algebra, just find a way to visualize it. Going up. And the player's at the bottom of the screen, but the level is scrolled to the top. And then it kind of jumps to the bottom. This is wrong. Unexpected. Because the new scroll X is based off of the old level scroll X. Oh. Which would cause it to do nothing. Let's try this. Activate the scroll next based off of clamping the X and Y values. Okay. Going up. Oh, did you see that? Vision still works, so go back down, make sure that still works. There's a little bit of flashing there. I wonder if we can clean this up a little bit. Because we're scrolling here, and then if the force update is true, we're also scrolling here. So let's put all this stuff in an if block. The else block. So we'll do one or the other. Here goes. XX is unknown in this context. On update line 6. Find that. Be that way. Wanting to me to define my variables before I use them, isn't that rude? It's actually quite reasonable. In case there's any doubt. Alright, here goes, and... Yeah, it still flashes a little bit, but... that might just be a side effect of how it loads the new map onto that same display layer. And it could be that the only way to make that flashing go away is to have some sort of transition screen, like leave the map, fade to black, load the new map, fade back in. That'll probably be how we resolve that one. And when we change maps, I want to experiment with having a little modal dialogue pop up showing the name of the map. I like how you would in the old Final Fantasy II game. So that's coming up real soon. I need to decide if I'm going to handle map transitions sooner or later. And those flashing doors, I've about had it with the flashing doors. I'll tell you the way we're going to solve that. We're not going to do it today. But basically, look at our tiled map. The door is on our decoration layer. Everything in the decoration layer is going to be animated, if it has an animation. We need to move that door up into the entities layer. So what we're going to do soon is, let's see, we have object, class is NPC. We're going to create a new type of class called door for managing all of our doors. But I think this is all we're going to do today. I think getting those map transitions worked out was pretty neat. Or the camera movement. I still want to do more with map transitions. I think next time we talk, we're going to review how to do the fade in and fade out. And maybe stick a little modal, not a modal UI, but flash up a little display showing the name of the map. I think that could be nice. So that is it for today. Thanks for joining me. See you later.